SSB, which means single sideband modulation. Single sideband modulation. Okay, SSB. Now, we have modulator. We have modulator. We will give carrier signal, message signal to the modulator. We are getting the modulated signal S of t. Modulated signal S of t. Okay. If the modulator is AM, okay, if modulator is AM, okay, so message signal spectrum will be a single triangle. Message signal spectrum will be a single triangle, and output modulated signal spectrum. Modulated signal spectrum will be S of F at plus Fc, at minus Fc, the triangle is shifted, and along with the triangle, one carrier component is also present. Along with the triangle, one carrier component is also present. Okay, this is about AM. This is about AM. And also we know the height of this AC mu by 4, okay, and then here it is AC by 2 is the height, AC by 2 and AC mu by 4, AC Ka by 4 I think, in multi-tone. Single tone means mu by 4 and multi-tone it is Ka by 4. Ka means amplitude sensitivity. This is about AM. This is about AM. Now coming to DSBSC, what we have seen in DSBSC, if the message spectrum, same message signal input we are giving, so this diagram will not change. Same input we are giving, this diagram will not change. But in the spectrum S of F, okay, so at plus Fc and minus Fc, plus Fc and minus Fc, triangles will be present, no carrier components. Triangles will be present, no carrier components. This height is nothing but AC AM by 4. AC AM by 4. Okay, AC AM by 4. This is about DSBSC. Now, single sideband. So here we are familiar with upper sideband, lower sideband. If you divide this into two halves, okay. This is upper sideband, lower sideband, and this is upper sideband, lower sideband, okay. And no carrier component present in DSBSC. Now I am going with SSB. The present third method is SSB, single sideband modulation. Single sideband modulation, SSB modulation. Okay, so message spectrum will be same. Message spectrum will be same. M of F, same input we are giving in all the techniques. But at the output, you will have either on the positive side or on the negative side. Only one sideband will be present, either at plus Fc or at minus Fc. Only one sideband will be present. Okay, so this is about single sideband modulation. This is about single sideband modulation. So all these are in multi-tone techniques. All these are in multi-tone modulation. Multi-tone modulation. In single tone means we will have pillars. Instead of triangles, we will have pillars. Okay, that is about single tone. I will show you about single tone also. In single tone modulation, okay. So output side, input side is same. Output side, we will be having S of F and three pillars are present. FC, FC plus FM, and then FC minus FM. At the center, you will have height pillar and two pillars like this. This is AC by 2. This is AC mu by 4. And this is also AC mu by 4 height. Similarly, on the negative side, at minus FC plus FM, and then minus FC minus FM. Three pillars are there. Okay, center and the sideband pillars. Center is AC by 2. Sideband is AC mu by 4. AC mu by 4. Okay, this is about AM. If I take DSBSC, just to show the difference I am doing in the same slide, okay, same PPT, same slide I am doing. You can redraw the diagram. Only carrier component will be missing. At FC, no pillar. At FC plus FM and FC minus FM, we will have the pillars. FC minus FM, we will have the pillars. But the pillars height are AC AM by 4 and AC AM by 4. This is the spectrum in DSBSC. At FC, we don't have any pillar. FC carrier is suppressed. Okay, double sideband, suppressed carrier. Double sideband, suppressed carrier. So these are the frequencies with respect to minus FC plus FM, minus FC minus FM. At carrier, we don't have any pillar. Okay, height is 0 at carrier. AC AM by 4 and AC AM by 4. Okay, these are the heights. This is about DSBSC. This is about DSBSC. But for SSB, now I am going with SSB, single sideband in single tone modulation, single sideband modulation. Okay, single sideband, single sideband. Here, this is upper sideband, this is lower sideband, this is upper sideband, this is lower sideband. Okay. Now, we will have the diagram in SSB, only one sideband is present, S of F. Okay, only one sideband is present. Plus FC, then FC plus FM, FC minus FM, minus FC plus FM, and then minus FC minus FM. We can have either upper sideband or lower sideband. Okay, so I will take either upper sidebands. Okay, this is upper sideband, or same diagram. Okay, lower sideband, same diagram. We will have pillar at FC minus FM. Okay, lower sideband pillar, or minus FC minus FM. We will have the lower sideband pillar. At minus FC plus FM, no pillars. Okay, plus FC plus FM, no pillars. This is about the single sideband. One pillar is cut off. In simple, one pillar is cut off. Okay, height remains the same. It is AC AM by 4 and AC AM by 4. Okay, it may be lower sideband, AC AM by 4, AC AM by 4. You understood the difference? In AM, we are having carrier component and sideband components also. Okay, in AM, in short, in AM, we are having carrier component plus upper sideband component plus lower sideband component. But in DSBSC, carrier is not there. Only upper sideband component plus lower sideband component are present. Okay. In SSB, we will have single sideband. Single sideband means we will have USB alone, or LSB alone. Okay, upper sideband alone or lower sideband alone. This is case 1. Okay, upper sideband alone present. Case 2, lower sideband alone present. This is the difference. You need not by heart any of these diagrams. Okay, you need not by heart any of these diagrams. So whatever I have given in white color, you remember. Whatever I have given in white color. In AM, we will have carrier, USB, LSB. In DSBSC, we will have USB plus LSB. In single sideband, we will have either USB or LSB. Then if you remember the first picture, AM picture, okay, AM S of F, this picture, then accordingly you can delete whichever components absent in the DSBSC as well as SSB. Okay, so this is about the single sideband modulation. So if you remember in the first case itself, AM types, I have told you what are the types of amplitude modulation. I told you AM is